So the energy for the black and white television is let's see. So energy equals power times time. And so that's equal to, so this is for part A, 90 watts, and then the time is 1 hour. And now we need to convert watts. Watts are so a watt is a joule per second. All right, so we need to change this hour to seconds. So I know that there are 3,600 seconds because I multiply 60 minutes times 60 seconds. So this is seconds in 1 hour. So I'm able to cancel these units. I'm canceling these units. I cancel my seconds, and I'm left. So if I change this watts to joules per second, joule per second, then I can cancel those seconds with this seconds, and I'm left with joules. So I get 90 times 3,600 is equal to 324,000 joules. So that's for part A. And now for part B, we need to find out the time. So let's find out the power for our color television. So power here is going to be V times I. And so we have that's equal to 120 volts times 2.5 amps. And so when we multiply that, we get 300 watts. And so the question is, how much time is required for it to consume the same energy as the black and white model does in an hour? So now, I know that power is equal to energy divided by time. So if it's energy over time, then I can solve. So energy is equal to power times time. Power times time. So now I have 300 watts, and I'm solving for time here. So I can divide both sides by T, and I get divide both sides by P, and I get time is equal to energy divided by power. So when I solve for T, I get 324,000 joules divided by, now 300 watts is 300 joules per second. So my joules cancel, and I'm just left with seconds in the denominator of the denominator. So I end up here with, I think it's 1,080 seconds, and let me double check that. 324,000 divided by 300 equals 1,080. And when I divide, I'm trying to find minutes, so they're times 60. Whoops, no, that's not what I want to do. I want to divide. So I want to divide 1 minute is in 60 seconds. So I find that my time is equal to, when I divide, I get time is equal to 18 minutes.